And welcome back, guys. Today we're gonna print this part in ULTEM 9085. Now that's PEI, or polyether imide, and it's a very high temperature, very robust polymer designed as a metal replacement. So this whole project actually spawned from a video posted by Fly with the Guys, and somehow through the grapevine we got wind of, hey, this part was 3D printed, but you guys are specialized in these high-end materials, so you guys should do it. And so we did. We actually modified the part, changed it a bit, and printed it out here in ULTEM 9085. And today I'm just gonna show you the workflow and how easy it is for you to do when you get your machine like this. Okay, so let me actually tell you what the functional part of this part is. Really, we've got this thing. Now this is an amperage current sensor. So this is gonna sense a wire that goes through the middle of it. It's gonna sense how many amps it's drawing. So you can see this is a press fit, and it just fits right in here. So that just goes boop, just like that. And you have your parts. The wire comes through here and it holds the wire centered, and then this is gonna sense the amperage draw for that aircraft motor. Originally developed by General Electric, I believe, and then bought up by SABIC a few years back, this material is rated for aerospace and often medical, and really good for a lot of automotive. Now, what makes it that way? Really, it's the flame smoke toxicity rating, or the FST rating. And this is UL94 is the standard, and this is V-0, meaning it is self-extinguishing, low off-gassing, it won't drip burning bubbles of fire and whatnot like maybe a nylon or a polycarbonate would. And so that makes it much safer for flying in aircraft. If you go onto a commercial aircraft, you'll find most of the tray tables and the window shrouds and things like that are actually made of ULTEM 9085. And you've also seen Formula One and Formula SAE printing entire intake manifolds out of this material for their race cars. We also see it a lot in medical. So if you are a machine shop, maybe doing aerospace stuff, and you're making components, or maybe you design aerospace parts that you sell to your customers, and you're using materials like this, then we're going to be printing on the 22 IDEX V3 today. And this machine, an incredibly affordable price for what you're getting, can do a ton of these parts, and it's probably one of the best ROI machines on the market today if it applies to you. Now, it's not for everybody because it is specialized for high temperature advanced engineering thermoplastics, and if you're making money with that, we should talk. So first thing I'm gonna do is head over to the computer. You can use any smartphone, tablet, laptop, or PC, or Macintosh, or any kind of internet communications device to control the printer. You just need a web browser and an IP on a local network, or you can do Ethernet, etc. So I'm gonna use this computer here, and the first thing we're gonna wanna do is check our temperatures and make sure the machine itself is getting ready. So we're gonna set this to about 160, and we're gonna set the chamber to 100, and then we'll leave the nozzles where they are, and that's gonna preheat soak the machine. It's 200 pounds of steel. It's gonna absorb a lot of heat. You need to have it on for about an hour or so to make sure it absorbs all the heat and it's not dropping the temperature constantly. So we always preheat the machine, and then we're gonna go slice our part. So in here, I've got my STL file. As you can see, it is a redesigned version of the part from the guys on that channel. So we don't really want to print in this orientation. There's a much better orientation. So I can use the tool right here called Place on Face. And I'm gonna select the back face because that's designed. It's flat. It's got everything touching the build plate. So when we go slice it here, we can see there's no floating regions or hanging regions, etc. Now, we also know this part has some challenges when it comes to warping. It's a round surface, and it's got some very small offshoots, so those areas tend to warp more. And we got a couple options. We've got obviously nanopolymer adhesive, our adhesive for these high-temp materials. That'll be applied to the carbon plate before we print. And then we've got brims or lily pads, also known as mouse ears. And these are little sacrificial pieces of plastic that connect to the part and connect to the part itself down to the bed. So I'm just gonna show you what that looks like and how easy that is. If you have a challenging part in these high temp materials, this is a technique that might help. So in Prusa Slicer, I'm gonna go right click on the bed, and I'm gonna go add shape, and I'm gonna give it a cylinder. Technically, you could use any shape for this, but I'm just gonna go to the scale tool over here on the left, and I'm gonna grab the center one to scale it down vertically to make it really thin, and then I'm gonna make just the overall size smaller. So we wanna make sure this cylinder is enough for one layer, so I can look down in the right-hand screen here and see exactly how tall it is. Right now it's 1.35 millimeters, and so I'm gonna take that down. Cool, so the first layer is 0.2 millimeters. So I'm gonna keep coming down a little bit more, 0.2 on the dot, look at that. Now, I've got this, I'm gonna place it in the area that has trouble with the warping. This corner here, so I'm gonna select this part, Control C, Control V to paste another copy, put it on that corner, paste it again, and then these edges here also love to warp up at the ends. So we're just gonna give it that connection there, paste one more, place that where it goes there. So you can see these red circles here, which are indicating that we're having collisions, and that basically shows you the area that it needs to print. So what we wanna do is actually turn all of these parts into an assembly. So right here, we've got our parts. I'm gonna right click, and I'm gonna merge. And that's gonna put them into just one body and treat it like one part instead of 5 separate parts. In my experience, you don't have to be too precise about placing these. Just keep in mind you will have to cut them off in the end or sand them off, or you'll have to remove them in one way or another after the part's printed. So I like to put them on easy to do places for that. The next thing I'm going to do is double check my print settings. So we've got 0.12 for the overall layer height. This is going to give us a very high quality surface finish. First layer height is 0.2. So why are we doing 0.12 layer height for the whole part, but 0.2 on the first layer? Very simple. On your first layer, you want to ensure that it sticks to the build plate very well. By laying down a thicker, larger line of plastic, we're giving it more room for play in getting that perfect first layer adhesion to the build plate. So that's why we do that. Just another quick tip for you. Now, next, we've got 3 perimeters, which is the outer walls. We've got 4 solid layers on the top and 3 solid layers on the bottom. Usually you want to go a little more solid layers on the top, especially at lower layer heights like this, because if you don't, it's going to leave gaps and your top layers will then droop into the part and you won't have a good top surface finish. So more layers on the top surface finish or the solid layers on top is a good thing to do. Then we've got the shell thickness and we've got extra perimeters if needed. Seam positions, that's all looking good. Let's go over to infill. So this particular part is at a very low infill, 5%. It doesn't need a ton of strength. It's holding a very lightweight part. We've got our Hilbert curve pattern, which is a low warp infill pattern. So just a good thing there. Skirt and brim, we've got 3 loops, and the skirt is kind of like a purge tower. We use the skirt offset from the part so that before it starts printing the part, we know it's got good flow of the filament through the nozzle. So we're really just watching that, and if the skirt's having problems, you can almost bet your part's gonna have problems. So if the skirt's not working right, stop your print right then. Let's see what else we got. The brim width is 0. On speeds, in this particular case, Manuel out in the back decided to set everything to 40 millimeters a second, which should keep it very consistent throughout the whole part. And we'll check that out in this slice, looking at the actual speed in just a second. Next, we've got the advanced mode. The first layer is 0.6 millimeter extrusion width. The default extrusion width out of the 0.4 millimeter nozzle is 0.45, but for the first layer, again, we're going taller on the first layer for more material and wider. So it's a nice, thick, fat first layer connecting to that build plate. And then support material, we've got 0.35, so it's actually doing smaller lines for any support material. This part doesn't have any support, so that setting doesn't actually matter. All right, next we've got output options. This is where we're gonna set sequential mode, and we're actually gonna print 2 of these parts, but we're in high temp. We want the thermal mass to be gaining all that heat, so the next layer going down gets good layer adhesion. So we're gonna print not 2 parts at the same time, but we're gonna print 1 part and then another part, so that we get really good thermal mass, the best possible layer adhesion. So from there, let's check out the slice. So here we can see we've got our lily pads and everything else. Very low infill, almost no infill, practically zero infill. There's not even much space in this part for infill. I don't see any weird gaps or anything going on. Let's go over to the filament settings and check those out. So filament, we've got 390 on the nozzle. That's about right for ULTEM 9085. So 390 with ULTEM 9085 is a bit high, but we're using a hardened steel nozzle, and that's got less thermal conductivity, but more abrasion resistance, so we can protect all the carbon fibers and the glass fibers and stuff like that. But it also means we need to up our nozzle temperature 10 to 15 degrees Celsius. If you're ever using a hardened steel versus a brass or some other material like copper, nickel-plated copper, etc., then you will want to up that temperature to get the same results. So the part is looking good. I'm going to go back into viewing the part. I'm going to duplicate this. So let's go Control-C, Control-V. I'm just going to rotate them so they're facing each other, because why not? And then I just realized if you updated your slicer at any point, it's really easy to get the beautiful bed visuals back on here. You just go to Printers, then you go to Set, Bed Shape. All right, so we're gonna load that one in, and then we're gonna load in the STLs for standard mode. Hit OK and go back and look. Ah, beautiful. Now we can see the orientation of our parts on the actual machine, which is great. So I want these about in the middle. I'm gonna hit R to rotate with them both selected and just go about 90 degrees. I'm gonna place these with the front right about there in the center of the plate. All right, beautiful. Now I'm just gonna go slice again. You can always double check your G-code paths. It never hurts. Oftentimes it will save you. And we're good to go. So I'm gonna export the G-code. We got PEI 9085, current sensor mode, looking good, and save. Now, we're just gonna go back to the machine. Now we come back in here to dashboard, over to jobs. I'm gonna upload the G-code file. And it looks like I got thrown into some random folder somewhere. So I'm gonna go find my file. And here's the latest version. So I'm gonna upload that. You can see it's uploading right there, 35%, 50%, 70%. And then it's going to show up in the jobs right here, along with a nice handy dandy little preview of what your parts are looking like. So that's the file we use. Now let's prep the machine. All right, so our machine is preheated. We got the G-code uploaded and logged in. Now let's get it prepped and loaded with filament and the build plate. Manuel, let's get the filament in here. Perfect. So this is a vacuum chamber that we custom make to fit the 2.5 kilogram spools. Now what you do is if you have an oven, you bake your filament to dry it out, and then you stick it in here to lower the boiling point of the moisture, which makes it off gas all the moisture, and you get extra bone dry filament. I cannot stress enough how important it is that you thoroughly dry your filament every single time, even brand new out of the box. We don't know how long it sat there in a warehouse before it got packed up, so it might have some moisture content in there. Just dry every time and use one of our vacuum chambers. If you want a full setup, we've also got lab grade programmable vacuum ovens that you can even program for annealing and ramp up, ramp down if you like. All that available at visionminer.com, so check that out. But for now, we're gonna go over and get the machine ready to load filament. It's gonna heat up the nozzles, so let's do that real quick. All right, so today I'm actually gonna show you guys the manual method for loading filament. First thing I'm gonna do is I'm gonna set my nozzle temperature about at the extrusion temperature. I'm gonna go to 350. And now I'm going to move the X, well the Y, negative 100, negative 200, and then plus 50. And then I'm gonna go X plus 100, plus 100, and minus 50. It's a 350 by 350 millimeter build plate, therefore you can just calculate that in your head. We've got the nozzle roughly around the center. Basically, it's just to bring it closer to make it easier to load. That being said, I'm gonna bring the Y even closer to the front just to make it even easier. Okay, so now let's load the filament. The nozzle's already heated up. I'm gonna get my gloves on because I don't wanna reach in this hot machine and burn myself. So let's safety first, kids. Kids, you're not kids, you're a bunch of adult engineers. All right, here we go. So we've got the chamber off. Let's grab our filament and put this lid back on real quick. There's more filament in there. You've got the issue of it came unspooled. So how do we make sure that this isn't gonna stop our print halfway through because it's looped onto itself? Really, usually a simple thing. This is a pretty hot spool, so let's see how I can manage this. You can sort of grab a whole bunch of this filament and just pull it to see what's going over what. So, and really give it a look to see, is it spooling? Yeah, it's spooling underneath some other ones. But is that actually underneath it? Or is it just there? So if I give it some tension and keep pulling, I can see right there. You see that? It's spooled underneath that other one. So I need to pull that one out. And if this was a medical grade filament, I wouldn't do this with bare hands. There we go. I'm gonna maintain that tension, keep unspooling, and we're to the top. Very good, okay. So now this stuff is ready to go. Always make sure, dude, it's the worst thing when you start a 36-hour print and you come in the next morning and it's stopped at 1 inch because your filament was tangled. Always really keep a good handle on that, and always make sure to use these two little things, or the ones throughout, to secure the filament to the spool before storing it. All right, now I'm gonna come in here. I'm just gonna set the filament onto the little holder. All right, I'm gonna load it up into the machine and keep pushing until it stops. Okay, so now I'm gonna go back in here and we're going to go extrude. So I'm gonna do 20 millimeters at 3 millimeters a second, extrude. I'm just gonna hit this button a couple times and watch my nozzle. So then I'm gonna switch it to 100 millimeters, watch my nozzle. And if you're wondering if it's actually extruding, you can always look up into the machine and see the gears turning. And we're gonna hope that it catches, because if it doesn't, I'm gonna open up the top of the machine and just make sure it catches in there. Oh, we got extrusion, we're good, we're looking good, okay. That way, if you wanna load it manually, you don't have to wait for all the different dialog boxes and everything, and you know what you're loading. So when you get advanced, you've had this machine for a little while in your shop, you're printing stuff on the daily, you'll get used to it. All right, so I'm gonna extrude an extra 100 millimeters just to clear out any old filament in the nozzle or any contaminants that might be there from the last print. And if it were a service job, if you're a print farm or a service provider, a lot of the times the cost of a nozzle is negligible in relation to the cost of the part. So if you want to make sure you're getting beautiful, clean parts for some very high-end application, just replace the nozzle, sometimes a heat break before your print. All right, so we can get this away and vacuumed back up. And then we just want to prep the build plate. Now this is really easy. We made this thing back in about 2018 called nanopolymer adhesive, and it's a build plate specific adhesive that we designed for peak ULTEM PPSU high temperature thermoplastics that happen to work on everything. So if you're doing PLA, nylon, polycarbonate, ABS, ASA, anything else, this little bottle of stuff is an incredible value. I've done 45 plus prints on a PCTG print or a PETG print on glass, and it just kept working. I've done many prints on PLA. We have a bamboo that we coat once a month or so, we put more down. So really, really good value. It's an insurance to make sure your parts stick to the build plate and they're not warping and curling up in the corners, giving you parts that aren't just as awesome as you want. So on high temp, it's even more critical. I'm gonna do a nice bit in there. Take the little brush and just do little circles, just to get an even coating throughout the whole printing area. Beautiful. Now I'm gonna take this, I'm gonna slide it straight into the machine. But at the same time, I'm gonna pull out the purge that we just did. So we've got some extruded material here on the end of the nozzle. You just grab that, put that over there. So now, when I put my plate in, it is really important that you secure all 4 corners of the build plate. If you do not, you run the risk of the build plate shifting around. So you wanna make sure to tighten those down pretty good, and it will expand at temperature. And then to get to the screws at the back, I'm actually gonna move the build plate down slightly. So I'm gonna go Z plus 50. All right, I'm gonna go down another 50. Now, there is a chance, because of the way the PIDs and everything work, that if you get an error message putting a cold plate on the hot bed, it might be like, oh my gosh, we're not at the right temperature. Don't worry about it. Just click bed heater and click reset fault. Everything will be just fine. Make sure you also reset the temperature and make it active again so that it heats back up. Now, I've moved the bed down. Let me really get these screws nice and tight. Very good. All right. Grab any last little oozes off the nozzle and we're ready to start the print. So, I come back over to the PC. We're gonna go to jobs. We're gonna find our G-code file and we're gonna hit yes. And now, it's gonna start printing. Okay, so here it is. The first things it's gonna do is it's gonna calibrate itself. It's gonna home all the axes, and then it's gonna do automatic mesh bed leveling across the entire plate after doing true mechanical self-leveling with the probe as it's doing right now. So that's gonna prep everything up. It's gonna wait until everything's at the perfect temperature, and then it's gonna start printing. When it's done printing, this is actually a feature I really love. The chamber is gonna change colors. If there's an error or a fault, it's gonna turn red so you can see it from a distance in your shop. Uh-oh, it's red, why is it red? Let me go check it out. Or if it's yellow, that just means it's paused. If it's blue, it's in some sort of calibration state, and when it's green, you have a successful print. So, we're gonna let it do its thing, and we'll come back when it's done printing and show you how to take off the part. All right guys, we're back and the parts have finished. So now we're gonna take the build plate out and get the parts off. Now there's a couple little tools to be aware of when doing this. Now these do come in the starter bundle with the 22 IDEX, so you get obviously some leather gloves that help protect your hands from heat, and a scraper as well as a razor blade scraper, which actually works very well for getting under parts. As if you've ever removed parts with this kind of thing, sometimes you can damage the edges and the bottom edges, so it's nice to have a fine tool to do that. Now we probably won't even need either of these today, but I'll show you that, and let's go ahead and do that process. Now another quick tip is that if you cool the plate and then remove the parts with the standard carbon fiber plate that's included on the 22, then it's easier to remove the parts. Now if you don't have a cold concrete floor to set it on like in your shop, you can also use a wet towel. This will just help cool the plate down a little bit faster, give it a nice solid base to sit on your table, and you won't burn your table either. So let's go ahead and apply the gloves and we'll get this out of the machine. All right, so the audio guy is telling me the machine's really loud, so I'm actually just gonna turn it off by pressing that button so that the fans turn off, it quiets down, and as I reach in here, I can explain what I'm doing, which is just unscrewing the thumb screws on the build plate. There's 4 of them on all 4 corners. And then I'm gonna slide the plate right out, close the machine, and bring it over to my wet towel. Okay, so now we can see our parts, we can look at them. Ooh, listen to that. That cracking is the sound of the part releasing itself as the plate cools. So the internal stresses within the part in the polymers, this is a topic to talk about annealing, a future video, but you can hear it cracking as it releases itself from the plate. Very nice, very nice. So I can speed up this process. These parts, they're small enough, there's a small enough contact area where I should just be able to sort of, yeah, I can just apply a little bit of pressure. Oh, that one was already popped off. There we go. And then if you want, use the razor blade to get off the skirt. And we've got our parts. So what we want to do is we want to cut these off. So I'm just going to grab my wire cutters to start. These are just standard little wire cutters, also included in the starter bundle. And we're going to cut around the outline, the base of the part itself. I'm just going to cut off chunks here. And if I want, I can even go in there with a little razor blade and clean up those edges. But basically, on this part, this is basically done. This is gonna go inside an engine bay. It's the high temperature material that can resist all that. It can also resist the hydrocarbons and oils that are in engines, as well as the low temperatures of being at high altitude and the high temperatures of being in an engine bay. So very good stuff right there. Finished ULTEM 9085 parts for an aircraft engine bay amperage sensor. So let's talk about these parts a little bit. And this one, it's just kind of neat because we put the threaded inserts in there. Now the final part doesn't actually have threaded inserts, but you always want to keep in mind, this is something you can do. You can add metal threads to any 3D printed part with heated inserts. That's all you got to do. Now, another technique also, ULTEM 9085 loves to warp. All these high temp materials warp like crazy. That's why it's got a superheated chamber and super hot build plate. So still, some parts can be challenging and still will warp. So what you see here, instead of a brim, we've added lily pads or mouse ears. There's different names in the industry for them, but basically, this is just a simple cylinder placed on the corners where it warps the most, and it gives it more surface area on the build plate so that it doesn't warp as much. So another technique there, but what does it really mean to be UL94 V-0? Let me show you. Here, I have a partial print and a propane blowtorch. Let's see exactly what happens when we light this part on fire. And there we have it. It fully put itself out. No drips, no extra flames. It's self-extinguished after a few seconds. All right, so we got the fume extraction in the studio going now so we can get some really cool shots of this burning. Let's check it out. Okay, there we have it. Totally self-extinguishing. It's also fascinating how it carbonized and it turned into this, basically a dust material. Here, I'm gonna hold it in these, and let's just see how far we can take this.
Further down.
Okay, so that was, it definitely will not stay on fire, and if you noticed, it stopped smoking very quickly. That's also the low off-gassing. So flame, smoke, and toxicity. The toxicity level is also low because it's for airplanes. Okay, so that is a clear demonstration of the difference between a standard engineering grade PA6 with carbon fiber, that's a nylon carbon fiber, and ULTEM 9085, which is a UL94 V-0 rated materials. All right, so if you are interested in getting a 22 IDEX into your shop, give us a call or shoot us an email. We have the 22 and a slew of other high temperature engineering performance 3D printers and 3D scanners, of course, and the materials like ULTEM, PEAK, PPSU, and many, many more to basically handle whatever kind of application you've got that could use polymers, super polymers, engineering polymers, and more. So give us a call, shoot us an email, check out visionminer.com, and we are here to assist you figuring out what to get if you even should get it. Anyway, thank you so much for watching. Leave a comment down below with what do you want us to print? A material, a part, something crazy, a whole project? Let us know down below. Give this a like if you enjoyed it, and subscribe if you want more of it. But other than that, thanks again. Have a positive rest of your day, and I'll see you on the next video.